Hey guys, welcome to Code Decode. Today we are going to cover some important interview questions on concurrent collections and how do they work actually internally. We will also cover modCount, which was requested to us in the comment section. So let's get started quickly. A very tricky question in an interview is that can concurrent modification exception occurs only in multi-threaded environment, or is this fine that it occurs even in single-threaded environment? So the answer to this is no. It doesn't actually mean that when concurrent modification exception occurs, that means you are running your project in a multi-threaded environment. Even the concurrent modification exception can also come in single-threaded environment. I'll show you with a demo now. So this is my array list demo. I've created a list. I've just simply added 5 elements to it. Now I have an iterator which iterates over my array list, and I'm just checking while the iterator has next element, get the next element, print the next element, and if the value is equal to 2, please remove that element. Now look at this very carefully. From list you are removing an element, so you are actually changing the size of the list with this particular line number 20. So you are violating a rule. What rule you are violating? You are breaking the rule of not modifying collection during an iteration. So you are iterating over it because we have an iterator created over the list. With this iteration, you are removing an element. With this, you will get a concurrent modification exception. So the rest of the part doesn't even mean, because here only you will get concurrent modification exception. These code will not work. Anyways, this code was just for printing after modification what are the values left. So if I try to run it, if you can see, so I'll try run this for you first. So I have created an iterator. The value is 1. I've printed 1. The value is not equal to 2, and hence your code is still working fit and fine. With second iteration, value becomes 2. Your value becomes equals to 2 here, and this code of line works, and hence concurrent modification occurs, and this is the result of concurrent modification exception. If you can see here, there is a method in array list that is check for modifications. If you go at this line number, this is the method, and this is the mod count that I was talking about in the previous video, on which I have got comments that you need to understand more, and so I'll be covering that also in this video. This is a single thread example. There is nothing related to multi-threading in my code. This is a simple class. This is a simple main method. One thread is running, which is main thread, and no other thread is created. So the conception that whenever there comes the word concurrent, that means your environment is multi-thread is a loophole. It's not like that. When a concurrent modification exception can also come in a single threaded environment and not always in a multi-threaded environment. This particular loophole was because you broke the rule that you are modifying a collection during iteration. Now, how does Java knows that concurrent modification exception? And this will answer your mod count issue now. So basically it uses a transient variable which is called as mod count, which keeps the track of how many times a list is modified structurally. So this is important. What is mod count? So I'll show this mod count to you first now. Okay, so what is this mod count? This mod count is nothing but a transient variable which is 0 initially, and then expected mod count is nothing but initialized with the mod count itself. So initially mod count is 0. As soon as you start adding your elements, your mod count starts increasing, and hence keeps the number of structural elements in your array list. And then your expected mod count is initialized with the mod count itself. So with this particular thing in mind, we have 5 elements. Now your mod count is 5. Your expected mod count is also initialized to 5. With the iterator working on it, when your value becomes equals to 2, you are structurally removing one element, and hence your mod count becomes 4 after removing. And hence your mod count is not equal to your expected mod count, and hence you get concurrent modification exception.
Hey guys, being fresher is really hard. But looking for the offline jobs as a fresher is definitely much more harder. But is it impossible? No, now it's not impossible with re-level. The freshly graduate people are now looking for some financial independence and good professional experience, and the struggle for finding an offline good job is never ending. We all despise online hiring platform for one reason. Because we all know we are a bunch of lazy mortals who apply for 20-30 jobs on day-to-day basis, which not only dims your vibes but also demotivates and overwhelms you. What if I tell you that instead of going to all these trouble, you just give one test and let companies come and follow you? So doesn't it sound worth it? Well, it is. With re-level, all you have to do is give the re-level test. Your score will determine where you end up with. And companies will hunt you down, and you have to do is just say yes. Choose re-level as an ultimate fresher buddy to you and be able to get a job into startups. We always underestimate the power of startups. These newly funded startups are a very great place to start with, and re-level gives you a chance to be a part of them. So be real, it's nothing more you look as a freshers. All the very best.
Now, structural modifications are the changes to size. So, what do you mean by structural modification? The structural modification means the size of the list changes, which affects the progress of iteration and may yield to concurrent modification exception. Both iterators and list iterators detect this unexpected change because of the code fix that I've told you. This is the code fix which is worked upon with iterator and list iterator, because list iterator internally implements iterator and works upon only on list, and we do have array list here. So even list iterator we can use, but you will get concurrent modification exception that also. Now, what is the cause of this issue? Cause is the inconsistent mod count, because mod count was 5, mod count become 4 and expected mod count become 5, and hence they are not equal, and hence you get a concurrent modification exception. When you iterate over an array list, iterator's next method keeps track of mod count. If you modify it by removing or adding, it will not match the expected mod count, and hence it will throw concurrent modification exception. So you understand what is mod count, you understand what is expected mod count. Expected mod count is initialized with mod count, and whenever you change anything, your mod count changes and decreases or increases if you use the delete or remove or add method, and hence the expected mod count and that doesn't remain same, and hence it will get concurrent modification exception. Now, so we need solution to it. So we have two solutions for this. The first solution for working this particular line of code is you can use iterator method to remove internally. So rather than removing it from the list and using the list method to remove a value, rather use iterator's method to remove a value. With this also, you will not be able to get the concurrent modification exception, because iterator is the one who maintains the mod count. While removing, it will also decrease the expected mod count, and hence your code will not fail at this point of time. And after removing your this particular code will work particularly fine, and you will be able to see that after this particular line of code you will see 1, 3, 4 and 5 is a result because 2 is removed. So let's see this in running. So yes, 1, 2, 3, 4, 5 was the 1, and after removing, this is the list which is left with the 2, where the 2 is removed. Now this was one way, or otherwise what you can also do is you can use concurrent on write array list. This is for multi-threaded environment. So you can use iterator in single-threaded environment, but now you will ask me what will this iterator be working perfectly fine if multiple threads are working? Answer is no. Again, you will get some exception. So better to use in a concurrent collection whenever you have multiple threads working around. Use copy on write array list. You can also use the same thing in single-threaded environment also. So that's the solution, which is copy on write array list. So this is safe in both single threaded as well as multi-threaded environment, while your iterator technique is only good for single threaded environment. It will not work for concurrent threads working around. Okay, so we have made it copy on write array list, and we have uncommented the list dot remove method, and we are not using iterator because it is not safe with concurrent threads running around. So the output still remains the same with 2 as removed in between. So copy on write is the best solution. You don't have to see whether it is concurrent threads working around or it is a single threaded environment. You can always use copy on write, which is a thread safe version. Okay, so we have understood what is mod count. It is nothing but a variable, transient variable that holds the size, structural size of the list, and expected mod count is nothing but initialized with the mod count itself. This explains why we don't get exception when we replace existing element, because in replacing any element, you do not change the structural size. So basically, we understood concurrent exception occurs when list size changes and mod count is initialized to expected mod count. These are the main interview point of questions which you should remember. Now, we also know the internal working on write array list. It is a thread safe version of list and kept in a concurrent package. So if you can see, this is nothing but in a concurrent package for you. For every write operation, a separate cloned copy is created and JVM will synchronize the clone and actual copy. So you will ask me, this is something very similar to concurrent hash map that we have seen? Yes, it is. Every time a separate clone copy is created whenever you try to write anything. So this is very similar to one we have used in the previous video. So I'm not getting much focus into it. I have much more to cover in this video. Okay, so now we get concurrent modification exception as soon as the array list is modified. It happens because it is fail fast and because of the mismatch in expected mod count and mod count. Now what happens in copy on write array list? It's actually creating a separate cloned copy whenever a write operation is performed in it, and hence JVM synchronizes it. Now, since it is thread safe variant, it is all mutative for the operations, that is add, set and so on, and is implemented with a fresh copy of underlying array, and whenever you are done with your write operation, it will be synchronized. Now what is important part? What is the difference between hash map and concurrent hash map? So hash map is thread unsafe and hence you cannot use in multi-threaded environment, while concurrent hash map was thread safe as discussed, and hence there is two important point which comes with thread safety. With thread safety comes fail-safe behavior of concurrent hash map. That is, if one thread is iterating, another thread can update the same map. It will not give you concurrent modification exception. But this is the advantage. What is disadvantage? If it is giving you thread safety, it is giving you fail safety. What is the disadvantage? The disadvantage for sure is performance is low, which is not in the case of hash map. So if it is thread unsafe, the disadvantage comes is that it is fail fast and can throw concurrent modification exception if you try to change the structure or the size of the list or the map. But what is the advantage which comes with the thread unsafety? That is performance is high. So whenever you say one point, whenever there is they ask you, the interview asks you the difference, you should always say the 3 points simultaneously. That is, if it is thread unsafe, performance will be high, which is advantage. Disadvantage is fail fast, concurrent modification exception. If it is thread safe, then what is the disadvantage? Performance is low. What is the advantage? Fail safety is what you get. Another main difference between hash map and concurrent hash map is the hash map contains null keys and values both. But the concurrent hash map cannot contain null key as well as pair. So no null is allowed in concurrent hash map. Now what is the difference between array list and copy on write array list? Very important question. So again, the 3 points that I have told you remains still here. The thread safety is the point. So array list is thread unsafe. Copy on write is thread safe. What comes with thread safety? Fail safety comes with the thread safety. So when one thread is iterating, another thread tries to update the list, a new clone will be created and later JVM will synchronize it. While in case of array list, it is fail fast, and hence if one thread is iterating, another tries to change the structure, concurrent modification exception occurs. What is the advantage of thread unsafety? High performance. What is the disadvantage of thread safety? Low performance. Another important point is iterator can remove an element in array list. In iterative, try to remove an element, unsupported exception occurs is thrown. So I'll show that also to you. If I uncomment this iterator.remove on copy on write array list, what will happen? You should say, no, it is working fine. It will work in both single threaded as well as multi-threaded. But you forgot that iterator, if it tries to remove it, you will get unsupported operation exception here. So remember, this is very important and tricky part in terms of interview question. If you're using copy on write array list, what you cannot do to remove an exception, you cannot use iterator.remove method. Which sorting is used by the collections. So if elements are less than 7, then insertion sort is used by collections to sort the elements, while after you have reached the threshold of 7 elements, mod sort will be used to sort the collections element. If this is something related to data structures, if you want us to continue with these sorting algorithms and data structures, let us know in the comment section. We'll create a separate playlists for these data structures. So thank you.